Alright, some of you are going to hopefully turn a smile to this lesson because we're going to be simplifying radicals. It's not a major lesson for the Pythagorean theorem, but it is something that I want you to be prepared for. So let's take a look. Now, for this, the goal is to be able to simplify a radical. In this lesson, we want to define what is a radical. It is the symbol, the square root symbol. That's what a radical is. And then the radicand, let's say if we have a radical, whatever number that goes underneath, let's say 169. 169 is the radicand because that falls underneath the radical. Now the square root, that would be the value which when multiplied by itself is equal to that. So actually the square root of 169, if we're looking for it, that would be 13. Interesting fact there. And a prime number. A prime number is a number that is no longer divisible by anything but 1 and itself. So, well, I would say that 13 is a good example. You could say 2, 3, 5, 7, 11, 13, the one that I had over here. Any of those, you cannot divide them up any further, so it's just 1 and that number, which are the factors of that. So, alright, now let's take a look at a little bit more. Looking at perfect square factors. Those of you who had me for Algebra 1, you may recall some of these. And a factor or a number that does have a square root. So something like, I'm actually going to write a whole list of these, like 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, let's go a little bit more, 196, and let's just say 225 for now. Okay, that's actually 2 through 15 squared. So any of these, you could take the square root of 225 and get a whole number like 15. Or you could take the square root of 100 and get 10. So any of these you could actually simplify if you had a radical around it, because they are perfect squares. Okay, so let's try the first one. We want to simplify the square root of 100, which we just said equals 10. Something to keep in mind, when you take the square root, and this is a big thing for this lesson, when you take the square root, you must make sure after you simplify, there is no radical anymore. That 10 no longer has a radical. It's just plain 10, just a number. Okay? Please keep that in mind. So, alright. Moving on. For number 2. This is really what we're looking for. The square root of 18. Because that doesn't simplify so nicely like the square root of 100. But what we want to check, we want to see what is a perfect square factor of 18. One of your factors is 9. 9 times what? Well, 2. So you're always going to be searching for a perfect square because you're trying to reduce or simplify. So the square root of 9, that simplifies, no radical anymore. This factor of 2, that's only a factor of 18. It wasn't a perfect square, so it has to stay under the radical because that's a prime number now. So the actual answer simplified is 3 radical 2. Now some people say, yeah, but how come if I take 3 times 2 that's 6? Well, it's because you're supposed to square 3 to make it visible to put it back in. So 3 squared is whatever times 2. If you take 3 squared, that's 9 times 2, you get 18. So you would get back to your original, but whatever number that you pull outside always has to be squared if you're trying to check your work. Just a side note there. Okay, moving to number 3. Okay, so here we have the square root of 245. Well, if I take a look at this, 245, I'm trying to rack my brain to see what this is divisible by. I do know that it's divisible by 5. Now, if I'm just trying to do a little bit of side work, I don't want to use 5 unless it has a perfect square that it goes with. So let's see. 24 divided by 5 is, well, 4, 20. 45 divided by 5 is 9. Ooh, I like that. Why do I like that? Because 49 really is a perfect square. So if we're looking at this, square root of 49 and the square root of 5. If you multiply those, you get the original. But we are trying to go forward, not backwards. So the square root of 49 would be 7. Now, since 5 is a prime number, that just drops down. So we have our answer 7 simplified. Radical 5 doesn't matter. All we're trying to do is get it to this point. Okay. For the next one, we're looking at the square root of, alright, the square root of 432. Now, I will tell you, one of the easiest ways to get to your answer is to see, let's see, what is the greatest perfect square that is divisible from a number, say, like 432. Well, if I'm going just based off of what I know, I can't guarantee that I'll find that number right off the bat. But I want to show you at least one approach for how you can do this. Some of you may say, well, I saw another way, and I'm sure that can work. Let's take a look at different avenues. So, 432. I see the 32 in the back, and I'm thinking this has to be divisible by like 4 or 16 or something like that. So what I might do is actually check. If I take 432 and I divide that by, well, I know that 4 goes into 4 and 4 goes into 32. I want to see if maybe I can try 432 divided by that bigger number. Which actually, let's say I try that. So I get radical 16, and then if you take 432 divided by that, you have radical 27. Well, with this, the square root of 16, that is 4, so that part simplifies. Now with this radical 27, is that a prime number? No, it's not. And guess what? Even better, you can still simplify that, because I know there's a perfect square that can be divided from that. So 27 is divisible by what perfect square? 9. 9 and 3 are the factors. 3 is a prime number, so that one's going to have to just drop down. But the square root of 9 is 3. So if we bring down the 4 times the 3, that's going to be 12, and then we'll multiply it by that radical. So our answer is going to be 12 radical 3. Now let's say you think you found a faster approach. Some people may try where they're like, yeah, I found that 432, that's divisible by 144. And I mean, if you keep checking and you try 432 divided by every possible perfect square, You can ultimately find it in the end, but yeah, so we get 144 times, let's see, what is that? Just making sure. Sorry. 432. I'm trying to do this on my calculator. I don't work well with calculators. So we have radical 3. Okay, so 144 times radical 3. Now the square root of 144. If you do this, you need to know what the square root of it is. So that would be 12, and then radical 3 is prime, so it just dropped down, and you'd have your answer. Again, that one's quick, but you really have to be pretty awesome with number sense. Otherwise, you may want to try the original approach, which is break it down a little bit at a time. And again, the key thing that I keep saying, when you have something like radical 3, that can never simplify if you have everything else that breaks down. So, alright, here's our answer, 12 radical 3. Now let's take a look at the next one, 6 radical 128. When you get a problem like this, we are going to focus only on the radical 128 right now, because the 6 kind of represents something that's already been simplified. So we're just going to put that aside and then bring it back when we get to the end of the problem. So, radical 128. Now I look at that, I'm thinking, okay, honestly, I've worked with numbers enough. I do know that 64 goes very well into that. So like 64. If you take 6 times what, you get 12, 2. If you take 4 times what, you get 8, 2. So 64 times 2 is 128. And like I said, that's me knowing numbers. If you can find those values, perfect. Because the square root of 64, right off the bat, what would that be? 8. Radical 2, that is a prime number, so you drop it down. Now don't forget that that 6 from above has to come down here. So 6 times 8, our final answer isn't just 8 radical 2. It would be 48 radical 2. Alright, that's one that you really want to be careful on, that you don't leave off one of the coefficients that you have. And I'm just calling it a coefficient from now, because it's the number that simplifies and it goes before the radical. But you got to make sure to also factor that into your final answer. Okay. Next we have this last example here, negative 8 radical 294. So, looking at this one, again, hold off on the radical or the negative 8. Let's simplify 294. Well, the first thing I'm going to do is think, is 294 divisible by 4? Let's check that. No, it's not. 294 divided by 4 comes out as a decimal. Is it divisible by 9? Not even. 294, that was a decimal. Divisible by, let's say, 16. Nope. 294 divisible by 25, not even. Alright, finally, we can find one. If you take 294 and divide it by 49, you're going to ultimately find out that 49 times 6 is 294. Well, here's the thing. The square root of 49 is 7. Now, let's talk about the factors of radical 6. Well, if I break those apart, you got 2 and you have 3. Neither of those is a perfect square. Those are both prime numbers. If you break down a composite number and it gives you 2 prime, like 2 and 3 there, then that means you want to backtrack because you prefer to leave your answer as radical 6. So here we have 7 radical 6. Now don't forget we have to bring down that original -8 and we have to multiply that in. So we are about at our answer here. That's the times, by the way. So we get -56 radical 6. Dunzo. Okay. Don't let radicals scare you. Make sure you take your time. When I come back, I'll try to make sure I have more practice for you guys if radicals is something that we do need practice with. But good luck, and here goes part 1.